question that is being asked here. What we have to bother here, we have to again take into the consideration the charge of a system must be conserved, no? The charge of a system must be conserved. So where the charge must be conserved. So what charge enters, what charge leaves one terminal of the cell, that much of charge what mean? Should what will happen? Should enter the negative terminal. So here E3, I'll look at the E3. E3 is highest voltage. No? So from here, I'll assume that charge Q1 plus Q2, let it leave. So just this assumption, Q1 plus Q2. In that, Q2 charge, let it be here, minus Q2 plus Q1 minus Q1. This is only assumption what I'm doing. Sir, if you get negative Q1, I'll change the direction and that Q1 will come. And finally, so that Q2 and this will be Q1. Okay, we'll write loop equation, we'll solve for Q1 and Q2 after writing loop equation. After getting that loop equation, after getting that KVL, so using KVL, what happen? I'll get the value of Q1 and Q2. So I'll write down the set of equations here. Is it okay? Charge distribution fine. So look at this battery E3. It will push a charge Q1 plus Q2. So Q2, then Q1. Then what charge entered positive terminal Q1? The same charge should leave the negative terminal. And what charge left positive terminal of cell E3? That much of charge should enter Q1 plus Q2. So conservation of charge principle is what I obeyed it. So when you put same charge, the answer is no. So better if you get Q1 equal Q2, okay, well and good. But don't put QQ that one because we are not sure, no? So don't start the problem with assuming same charge in both the capacitors. I think this will be the wrong idea. Because if this resistor were not there, if this resistor and cell were not there, as they are in series, because of this, what happened? The charge need not be equal, and we are not sure. So therefore, I am assuming different charges. Getting this one? Okay, write the loop equation now. So first we'll get into the loop equation. Plus C1 plus Q1 C1 minus Q2 C2 minus E2 equal to 0. Okay, clear this? So there's a one equation. Then similarly, one more equation is needed. Plus C1 plus Q1 C1. And at steady state, what is the current to the resistor will be 0. Minus C3 will be 0. Or you can write here only. So or one more equation I'll write it. E2 plus Q2 C2 minus E3 equal to 0. Three loops are there, no? Three loop equation I'll write it. Of course, the unknowns are only Q1, Q2. Solving that, we'll get Q1 and Q2. I ended up like this. Q1 equal to 4.5 millicoulombs.
Q2 3.5.
3.5. Okay, after getting this, both I got positive. So definitely the charges will not be same. Are you getting this one? No. What about the heat generated? Work done by the cells. Initial energy in the circuit. Initial, there's no charge in the circuit. So initial plus work done by the cells. Final potential of circuit plus heat generated. There's a formula. Initial energy in the circuit 0. Work done by the cell. Q1 plus Q2 into E3 minus Q1 into E1 minus Q2 into E2. Why negative sign E1, E2? Positive charge enters positive terminal. Negative work. Positive work. Negative work. I'm just picked up a problem where two different capacitors are there. There's a method what we can manage here. So minus Q2 E2 This is plus energy in the circuit, Q1 square by 2C1, Q2 square by 2C2 plus H. Solve all this, you'll get expression for, okay, here equal to, expression for heat generated. Answer will be 1.625 joule. Check the calculation, you'll get it.
Sir,
Yeah.
from here, the heat that we get is the net heat generated by the circuit. But is asking the heat dissipated along the resistor itself. Not like this might include the heat dissipated along the capacitor also.
I don't know what you are asking question.
I am telling that this is the net heat dissipated by the circuit, but is asking the heat dissipated along the capacitor, along the resistor.
Why capacitor will dissipate?
Capacitor will also dissipate. We don't know, no, sir, it will dissipate or not.
Why you are killing the capacitor chapter? We are ending up actually, and you are killing the total capacitor, the storing element. It will not dissipate, it will store. It will store energy, it will not eat up the energy. Only the resistor, what happen, will eat up that energy. Means it will convert that electrical energy into heat permanently over. The capacitor, not that you give energy, it will return back. So who will dissipate here? Only the resistor, no? The resistive, the resistor is what? The dissipative element. Of course, if the capacitor is having some conducting medium, if the dielectric slab is made up of conducting medium, if it's having some resistivity, it will dissipate it. But till now, I think I didn't introduce. Tomorrow, I'm going to discuss about that. Capacitors are ideal over. So circuit means here it's only R. The resistance of the circuit is what is bringing R, that one. So here what all heat generated will be across R only. Remaining all here, this wire is ideal, this wire is ideal. All the wires are ideal. Okay, fine. This
Yes,
is
sir.
what